that is fairly complex as quickly as I can, hopefully bringing clarity to it, not confusion, because there is a lot of confusion around what exactly is robotic process automation and what it isn't. So we're going to go through, I'm just going to skip this because we're going to get through all of this stuff one at a time here. So first of all, what is it? Just like almost any new technology, AWS and cloud technology, you know, there's a lot of confusion around new technology, and this is definitely no exception. It is within the field of artificial intelligence, but it is not artificial intelligence itself, so it's kind of a subset of AI. So if I say AI, I'm talking artificial intelligence. Within artificial intelligence, first of all, step back a little bit. Artificial intelligence is sort of we're led to believe it's a new thing, and in many ways it is, and in some ways it isn't. So we've had AI for a long time, but it's a very narrow version of AI. So when you think of anything where you push a button on a computer and something happens, or a process runs in the background and something is automated, technically that is artificial intelligence. It's what we call ANI, which I'll get to in just a minute. So then there's a difference between IT automation, so I've abbreviated that here, ITA, which is what you think of as traditional automation. That requires programmers and all that. This is process driven, so you have some kind of process you need automated, and you use code to do that. Robotic process automation is sort of an abstraction of automation. I'll get into what that means here in a minute. It also is process driven. So these two are alike in that they're both process driven. When you get into additional fields, these, as you'll see here, are data driven. So from here forward, we're looking at data driven automation. So machine learning is a subset of AI. And here you're looking at essentially what we're trying to get at is learning within systems. And this is what, right now, this is what we think of as AI. This is also called weak AI or specialized intelligence. This also is data driven. So instead of having a process that you code, you have data that then you have code that runs against that data and does something based on it. The next step is the step that gets really cool. I mean, artificial narrow intelligence that we have now, done a whole lot of things for us that have been super useful. When we get to, this is future, we have no idea when we're going to get there, although it seems like it's getting closer much faster. This is where we call it strong AI, or this is human level intelligence. This is where computers actually reach a state where they're as smart as we are. Again, we're not there yet. If people say, oh, this is going to happen in 12 months, that's probably very optimistic to say the least. But it's probably not 100 years away either. It could be, I've seen speculations anywhere from 15, 20, 25, 35 years. So it's not super far away, we don't think anyway. This also is data driven. Excuse me, pointing the wrong one. So this is data driven. The next one, artificial superintelligence, this is where it sort of gets scary. So general intelligence is pretty neat. We have computers that are as smart as we are. Superintelligence is where we don't really know what exactly is going to happen because the rate at which they can learn is so much faster than what we can learn. We don't even sort of know what we're going to be creating at that point. And most likely, the theories today say that this will actually invent this. We will not invent the superintelligence that comes along. Artificial general intelligence will actually invent that. So we'll have to be careful. The robots of the robotic process automation, I want to make sure it's clear that we're not talking about hardware robots. We're not talking about what you typically think is a robot. We're talking about software. It's running on hardware, because all software runs on hardware. But we're talking about software. We're not talking about some machine-looking or human-looking thing sitting at a desk. And then these software robots, in terms of RPA, are created in a GUI, we call it a GUI, a graphical user interface, similar to something like Visio, Microsoft Visio, if you've done that, where you have lines that you can draw before things, and you have different shapes and things, and you have decision points and that kind of stuff. So you're not talking about programming, you're talking about somebody who knows a process. They can map that process in a graphical user interface, and then that process behind the scenes is actually writing code, and then that code runs and does something. In general, no code is written by the person who puts it together, though. So for a working definition for RPA, RPA is a category of software used to automate tasks that are typically performed manually by humans. So in short, and I'm not sure this makes it any clearer, but RPA is an abstraction of automation. So instead of coding the automation, we're actually abstracting it. The code is being written on the back end, and we're abstracting it and putting it into a user interface that you manipulate. So what does this mean? RPA software enables non-programmers the ability to automate tasks that would traditionally be performed manually by humans. This automation is created by using a graphical user interface instead of having to program the automation using code. The purpose, first, is to understand what is not the purpose. It is not designed to interact with humans. So when you have chatbots and IVRs and those types of things, that is not RPA. What they are designed to do is to do things on behalf of humans. So forms are a great example of this. So you have forms, you're supposed to add text into various fields in the forms. Typically humans do that manually, and an RPA, you can have forms in different systems that an RPA can take it. I'll simplify it. A human can put it in on one form, and the RPA takes it and puts it across all of those other forms. So if you have an address change or something like that, an RPA can automate that. I'm getting ahead of myself a little bit, so I'll just slow down on that. And I want to make a comparison again between the IT automation versus RPA. So the main difference is that the IT automation requires programming. The RPA is something that uses a graphical user interface. Types, there's generally two divisions within RPA. You have attended, which is when you have a robot that interacts with humans, so your customer service agents, and then they control and initiate those automated tasks. Typically, these are associated with front-end things that happen on a monitor compared to something that happens on a server in the background. So the front end is where these happen. Examples here include opening new cases, updating customer records, like what I just talked about with address changes between 3 or 10 or however many different systems, logging into various systems, so the RPA can actually get access to the passwords that are stored in a secure location, and so forth. I'm going to skip over some of these just due to time. Unattended is when a robot completes tasks autonomously without human initiation. These are tasks that are associated with back-end tasks. So these happen on the server side, not something where you have a form and a customer service agent is doing something with that form and then the robot takes it from there. This is something the robot does on the back end on its own. So this may be somebody calls in and an agent picks up and the person needs to know the status of an order. That order may be stored in let's say an order could come in on one of 5 different websites, and you don't know that as the agent, and the customer doesn't have an order number. All they have is their email address. So within one of those systems, they placed an order. You don't know which one, and the only thing you have is their email address. So typically, what you would have to do is go to the first one, log in, type in the email address, see if there's a record that pops up. See also if that record is a new order, one that they're asking about, and so forth. And you'd have to do that across however many different systems. With RPA, you take the email address in, you hit search. RPA logs into all those different systems, searches that email address for all those different systems, and comes back to the relevant orders. So that can happen within a matter of a few seconds. It could be 30 seconds instead of 3 or 4 or 5 minutes. So you can cut time drastically in a situation like that. Again, I'm short on time, so I'm going to skip some of these other ones, but that at least gives you an idea there. So benefits of RPA. It's simple to use. That's relatively speaking. There's still software that you have to learn how to use, but you're not learning development. You don't have to learn a language and become a programmer to do this. Typically they say no coding knowledge needed. Some of them actually allow you to do a bit of both. So people don't multitask efficiently. Contrary to what a lot of people say, you know, it's great to put I can multitask on my resume and so forth. Interestingly, when you look at the psychology of how people work, your brain is meant to do essentially one thing at a time. So computers can do all kinds of things concurrently. They have no issues with that whatsoever. And then it also helps you to standardize your service delivery. So you have more consistent customer experience. And a couple examples here. Let's say you have an insurance claim that comes in. You have to take that information in. The agent gets another call, so they put that on hold. They have all the information, but they're waiting a little bit. They get back to that later. They realize they have to put this into several different systems. They do that. The weekend comes as they're waiting for additional information to come back from underwriting or whatever. You go through the next week. They are now set to call that person back to tell them, but they're waiting because they have other things to do. There are processes within that whole situation that can happen in the background once you get that initial information from RPA. There's examples that I could bring up again, we're short on time, but where you can cut that time down from 3 or 4 days into 90 minutes. So obviously it's going to depend on underwriting and things like that, but you can cut that time down drastically. Not to mention the fact that you can, if you have to call somebody back and somehow that gets lost in the mix, then they call in and they're not happy because you haven't returned their call and so forth. So if you can do that quickly, that's less likely to happen. Error rates are almost near zero. So when you're copying and pasting and you're a person, you're going from one system to another, you have to know all of those systems, which fields go where and so forth, which ones you can skip and whatever. In RPA, you map all of that out. It copies and pastes, it knows exactly where to put it, and it's all done. Essentially, you have a zero error rate unless you unless you automated it and corrected. Reduces agent handling times. You can automate repetitive tasks. You don't want to automate one-off tasks because that doesn't save you any time. Anything that you do with RPAs needs to be something that's repetitive. Security advantages. So you have, they can operate in fully compliant environments. Whereas, so if you have PCI requirements or any of those types of things, RPAs can do that fully within that environment. You never have to worry about any compliance issues. They can also access confidential and encrypted user data because you can give them access to that directly, and you don't have to worry about a customer service agent going in and you know, they need to remember something between screens, so they jot it down or something like that, or they paste it somewhere they're not supposed to or whatever. So obviously they're not supposed to be doing that, but those things can happen. It also frees up your agents to then develop customer-centric skills. Why would you use a person to do something a computer can do way better? Instead, you use the person to do what people are good at. And people are good at solving problems in terms of customer service problems, selling, advising for empathy, de-escalating customer issues and things like that. Computers are not good at those things, at least yet. And then you also have fraud detection. So they can actually, when you pair this with machine learning, the RPA can then, the machine learning can go in and basically look for patterns and find issues where there's possible fraud. The RPA then can send signals out that says to somebody on the customer service side or security side, says, hey, I think we have a problem here. And then they can do more research there. Keys to success in this field, again, I've gone over this, extremely fast, at a very high level overview. So lots of missing details here, but first of all, always start simple. Do a proof of concept and then move on to pilots from there. Don't just jump into the deep end on this. Be careful, start slowly. For some general guides to complexity, you want to keep this to, in terms of the steps in the process, to somewhere around 5, give or take a couple. Keep the number of applications involved. So if you have a whole bunch of applications that your agents deal with, you want to keep the ones that the RPA is interacting with, again, to a fairly small number, 5, 8, somewhere around there. You don't want 30. And then keep the number of clicks relatively low. So as you go into different fields, each one of those involves a click. It's either a tab or it's an actual click in the field or whatever, however you want to measure that. But you don't want that to be too complex. They get a little unwieldy, very complicated to manage if they're too complex. And know when to use it. The things that you want to use RPA for are when you have processes that need to be automated that generally have higher rates of repetition. So when you're just, again, you're making a change in an address, it's done across 9 different systems, that's perfect for RPA. Lots of other things, or when you have invoices that come in and you can read those invoices and then take that information and put it into various systems, that's a great application for RPA. And the time saved by RPA should be significantly greater than the time spent completing the task through traditional means. So whether it's, generally it's going to be humans doing that. So if you have a one-to-one relationship where it takes a human 5 minutes to do it and an RPA 5 minutes to do it, which I don't know how that could ever happen, but if that would be the case, that is not a good fit. You want to cut that time in half or greater than that sometimes, or it depends on how long the process is. Obviously, if it's a 20-minute long process, and you can cut it down to 13 minutes, that's not half, but that's a lot. So you need to use it judiciously. You want to have a central system that controls the automation. This is critical. Otherwise, essentially all you're doing is scripting. So RPA is you can have several automated processes that are all managed sort of together in one system. And then be sure to use desktop analytics to help you to understand what is best to automate. So most RPA tools, almost all of them, come with task recording tools. So you start out and you start putting information in, and then you do the clicking and the copying and pasting and all those different things. It records all of that, and as you do that, it builds all of those the processes that it needs to do in the background. So that helps you to automate it, makes it much easier. And then finally, you want to work with somebody who's a trusted solution provider, so that this is a field you probably don't want to get into on your own unless you have a team who's already experienced in it or experienced in other things that are very similar to it. That's it. It was a whirlwind, but hopefully that brings a little bit of clarity to it.
Thank you. Please about automation system, in which languages can be used, and for the machine learning, can we use, for example, Arabic or for example, and in which time to use it, for example, for our solution.
So which language, when you say languages, yeah, when you say languages, you're not talking about programming languages, you're talking human. So you should technically be able to use any language with RPA. So it's essentially, it doesn't matter. Because what you're doing is you're, since it's not programming, it's not actually reading, like forms is, again, it's an easy example to use this, where you have forms that you're filling out with repetitive data on each one of the forms, and you have to copy that across. So you map that using, it's almost like what you're doing is, you sort of are in certain systems. So you're doing almost a screen recording, and it records what you're doing, and then So it knows, it can read the code behind your, or your HTML, JavaScript and all that stuff. And it will say, okay, it went from this form field with this ID, into this form field with this ID, into this other system, and so forth. So it can map all of that as it goes through those systems. So it doesn't matter what language it is. It just goes, here's a text field. I'm going to copy that information and put it over here. This is, these are numbers, and it's maybe constrained to numbers. I'm just going to copy what you put in there, and so forth. It does get a little tricky. The harder implementations are when you have something where, let's say you get invoices in from a client, and you need, so this RPA generally, the more powerful RPA is when it is also combined with other forms of AI. So where you have machine learning, or you have other forms of, there's a million different things out there. So you have text analysis and things like that. So an invoice comes in, they're always in a PDF format, and you can grab an invoice number, a date, the company it came from, what the invoice is for in terms of the product or service, what the amount is, and so forth. So it can go through, read all that information out, and capture that, and then go in and put it into an accounting system. And then it also might go into some other system, and it can, so that's where you have a higher level AI doing that, where there's probably going to be, there will be machine learning that goes into that side of it, with additional AI that will pull know which information to pull out, so there's text analysis and stuff that goes there, and then it takes that out, and then the RPA takes over and just copies and pastes and puts it in, pushes buttons, all those kinds of things. So it's not just copy and pasting, there's additional functionality that works there.
Thank you very much. I have a question about API. Is it about learning or is it about repetition? I mean, the system will learn when he repeats, or it is all about repetition? Because sometimes, for example, for a voice, the format of the PDF is not the same.
Right.
So he must learn. So if it's not the same, he will not recognize the person. And the second thing you told us about API, is it tools or is it programmation, or what is it? And if it's tools, what is the best tool? I mean, I didn't understand the API. It's about program or is it tool?
Okay. So first of all, it's a tool. Well,
it's a dumbed down programming.
Let me show you quickly, I have a few seconds.
Yeah,
just to
sure.
show an example
Sure.
of what it would look like.
Yeah, seeing it helps.
Yeah.
It is.
So this is part of the Infusionsoft, right? It's so basically we have a graphical interface, right? And you don't have to be a programmer to do this, right? So you define your process, right? And you start building the process in this graphical interface. I'm going to repeat this.
On the microphone.
So the main thing, and I know something to keep in mind here is this is one piece of software showing you how to create sort of like an email campaign that's automated that then takes somebody to a web form and so forth. So there's a million different things you can do here. This is one out of limitless almost things that you can do with RPA, and it's within one system. So there are RPA systems that you can get access to that will go across different systems. So you could integrate, you can do tasks across websites or across like SaaS solutions, things like, so you can have a CRM that you log into, that you do certain things in, that you maybe you get an email, it comes in, it grabs text out of that email and puts it into your CRM, for example. The billing one is an interesting one because, like you said, your invoices could be formatted differently. Even within one company, it might come in differently next time for whatever reason. It might have a different line break somewhere that puts the data in a different place. So it's not like you can just screen read it based on pixels where things start or something, because that would change. So invoices. So invoices are one of the ones that's more advanced, where you have to have machine learning, RPA, and some AI that's involved there. So that is not where you start.
Yeah.
That is, you start with simpler things like what Anwar just showed. You can go to things where it'll address changes and things like that. Customer record changes, where you have to put them in multiple systems. Those are good places to start because you're talking much simpler processes there compared to you get an email, it's going to have to be tagged some way with invoice or something like that in a subject line. There has to be some kind of identifier there. Now again, over time this is going to get better, but we're at the beginning, really, this is pretty cutting edge. So, and it gets into the very the bleeding edge, right? So, just start, if you're going to start slow.
Yeah, so I have an example actually that we're looking at in the call center that we talked about that we purchased. We have currently a manual process where our clients, they will send us tickets that we need to work on. And they can come in at any time, right? At 10 in the morning or 10:05. So they just go to their queue, that we have access to their queue, to their system, and they just start putting work for us. And then our process today is every hour, one person goes in, check all the queues, grab all the information, and put them in the system, or start assigning them to employees. Or if they have time, even half an hour, they can go and do it. And it's working right now, it's manual and it's fine, but we're looking at either do we want to develop something ourselves or looking at robotic process automation where it's always going every minute or every second and just kind of pinging all of those queues. And it's a robot just sitting there and then grabbing the information and actually now automating even the dissemination of the work to employees. So that's something that we're looking at. But a lot of applications right now in call centers and back office for this information. I was telling earlier, the guy from Mobilis here is that this is maybe something that you can look at to help with your staffing with automation, because to get it started is not that hard, because these automation companies actually they did all the legwork how to do it. So he can say, look, I have 5-minute call. If 2 minutes of it is really talking to someone, and 3 minutes I'm updating the information, and it's always the same. Actually, that's something he can automate, and now he can really have a lot more calls. And at the end, he just press the button, like update the address. They just write it somewhere, and then it goes and updates all the fields instead of going to every system. Our employees are doing that. A lot of call centers are doing that. The back office are doing a lot of this work in accounting, in ticket management, and it just started about 3 years ago was kind of the taking to it. And there are like some companies out there just doing that.
Just one quick comment, because I know you're interested in the technology aspect of these things we talked a bit earlier, right? So a lot of it is also used in software testing, right? Trying to automate a lot of the software testing because, it helps with, bug detection, a lot of regression tests, especially if you know exactly the scripts and what you need to do from a software perspective. And especially around that regression testing, make sure that you didn't break anything new by bringing a new code. You actually use this kind of concepts, right, in automation.
Well, it's interesting too, because with automating your bug testing and those kinds of things, we've done that before with scripting. So it's not even that we haven't been able to do that before, but we can do it easier now with RPA. So it's much easier to map all of that out, quicker, easier. And when you write code to test code, sometimes the code you write has bugs in it. So this also helps, Exactly, right. Infinite regression.
Yeah, I think the best analogy I can give, McDonald's. In the past, the people who worked at McDonald's, they would go, I want a hamburger, and I want fries, and I want this. So they are kind of going and press hamburger, and then they press fries, and and they do all that, and then giving the money, going back. So there was a lot of these steps, and then they dumbed it down. They made it dumb, the system dumb, because they just created like buttons, like shortcuts. So if I want meal number 1, they just press 1, 2, 3, 4. RPA is something similar in the sense of you don't have to be a programmer to do this. Really, all you have to do is be a logical person and know the process. As a matter of fact, you know that your employees or your supervisor or the manager knows that for me to update the address in the system, I go to this screen here, I fill out the information, and I copy it because I know I'm going to save it in CRM, because you need to put it somewhere first. And then I copy, and then I paste it into this system. Oh, and also I have to go and copy and paste it to the others. And then you open the system, and then you log into the system, right? All of these steps your employees are doing, and so all you have to do is just go and record that. Actually, you can record it in the screen, and then RPA is already so, oh, they went here, they went here, they went here, and then they know everything behind the scenes, and it does it for you. It's like magically, like the magic wand. It magically happens. It's crazy.
Well, and I mean the other thing, just to give you another. Hopefully this helps you understand kind of what it is. We have Photoshop today, if you're familiar with Adobe Photoshop. So to draw a line on a computer or a curve on a computer, you can do that through programming, right? So if you want to color a section of a screen, you can write a program to color that and to do shading and all these other kinds of things. Well, all Photoshop does is abstract that code out so that you're not writing code. You're moving a cursor on a page and clicking places to fill and do all these different things. RPA is essentially that same thing. So normally you would have to code these steps to automate a process. Well, it's abstracting that, giving you a graphical user interface where you drag and drop things and type text in, for if you want values put in or whatever, so that you don't have to know that code. So it's bringing that process out of there and abstracting it so non-coders can do it.
Now, if you're a coder, it's even easier.
Oh yeah,
yeah. I mean, but for business analysts, that's actually a good way to update the information.